Welcome to section 4.3, Right Triangle Trigonometry Part 2. We're going to be looking at the fundamental trigonometric identities. The first three are the reciprocal identities. Cosecant is the reciprocal of sine, so that's 1 over sine of theta. Secant is the reciprocal of cosine, so that's 1 over cosine of theta. And cotangent is the reciprocal of tangent, so that's 1 over tangent of theta. The quotient identities for tangent and cotangent are tangent is sine of theta over cosine of theta. And if that's true, then cotangent of theta would be the reciprocal of that, which would be cosine of theta divided by sine of theta. Let's talk about why that actually is, though. So sine of theta, if we think of our ratios, is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So you see that the hypotenuses cancel, and you're just left with opposite over adjacent when you divide sine by cosine. That's one of your ratios. What's opposite over adjacent? That's your tangent. So tangent of theta, when simplified, sine theta divided by cosine of theta, you still get that same ratio as opposite over adjacent. So therefore, cotangent is the reciprocal of that, and that would work out the same way. We're going to look at three more identities. These are called the Pythagorean identities. So we know Pythagorean theorem, a squared plus b squared is equal to c squared. What we're going to do with this is we're actually going to take this equation and we're going to look at some of the ratios by dividing by c squared. So if we divide everything by c squared, that will give us the ratio a divided by c squared plus b divided by c squared is equal to 1. Well, a divided by c, look at the ratio of the triangle. A over c would be adjacent over hypotenuse. So adjacent over hypotenuse is cosine of theta. So that's cosine of theta squared. B over c is opposite over hypotenuse, so that's sine of theta squared, and that's equal to 1. Now, so we don't have these parentheses, we actually write, and I'm going to write the sine first, but we write sine squared. We actually put the squared after the word sine of theta. That way we don't have to put parentheses in it every single time, and it's understood that when the square goes after the trig function, that the whole thing is being squared, not the word sine, but sine of theta is actually being squared. Cosine of theta is actually being squared. So here is one of your three Pythagorean identities. Now we're going to take this and we're going to divide the whole thing. Let me rewrite it real quick. By sine squared. So if we divide everything by sine squared, we will create another Pythagorean identity. So sine squared divided by sine squared is 1. Cosine divided by sine, we just did that one. Cosine divided by sine is your cotangent. So that's 1 plus cotangent squared of theta. And then 1 divided by sine squared is one of your reciprocals. So sine squared is the cosecant. So that's 1 plus cotangent squared of theta is equal to cosecant squared of theta. So there's another one of our Pythagorean identities. And we have one more. We're going to take the original, once again, sine squared plus cosine squared of theta is equal to 1, and we're going to divide everything by cosine squared of theta. And so sine squared divided by cosine squared, that's your tangent. So tangent squared of theta plus cosine squared divided by cosine squared is 1. And then 1 divided by cosine squared, using the reciprocal identity, is secant squared. So those are three more identities that we will need to know, which gives us a total of 8. So those are the 8 fundamental identities. We got 3 reciprocal, 2 quotient, and then 3 Pythagorean identities. In example 1 here, we're going to use the trig identities to find exact values of the remaining trig functions. Now we did this the other day, but we used triangles. Today we're going to use the identities. So knowing that sine of theta is 4/5, we can use the Pythagorean identity to figure out what cosine is. So sine squared is 4/5, so we can know that sine of theta is 4/5 squared plus cosine squared of theta is 1. So we know that's 16/25. Subtract 16/25 to both sides, and that's going to give you 9/25. And then you can take the square root of both sides, so cosine of theta would be equal to 3/5. So we know sine, cosine, and now we can find tangent by doing the quotient. So tangent of theta is sine of theta divided by cosine of theta. So that's using the quotient. So sine of theta is 4/5 divided by cosine is 3/5. The 5s will cancel out and leave you with 4/3. The other way to look at this is, remember, multiplying or dividing by a fraction, we multiply by the reciprocal. So 4/5 times 5/3, and that's where you can see the 5's cancel. So it's 4/3. So we have sine of theta was given as 4/5. Cosine of theta we found to be 3/5. And tangent of theta was 4/3. So that means we can find the reciprocals. So cosecant of theta is the reciprocal of sine, so that's 5/4. Secant of theta is the reciprocal of cosine, is 5/3. And cotangent of theta is the reciprocal of tangent, which is 3/4. So those are the trig functions, 6 trig functions, given one of them by using the trig identities. The same question, but answering it a little different, was how we answered it the other day, was by creating a triangle, calling one of our acute angles theta, and then doing the ratio opposite over adjacent using Pythagorean theorem to figure out the third side is 3, and then from there you guys can figure out the 6 ratios. So we really can answer the question 2 different ways, by definition of trig functions, or by now using the identity of trig functions. We're now going to use our trig identities to transform one side of the equation into the other. We only work with one side at a time here. So what we're going to do is kind of look at the more complicated side, which would really be this left side here with secant theta, cotangent of theta. How can you rewrite secant of theta? Well, one of the ways we can rewrite secant is using reciprocal identity, which would be 1 over cosine of theta. Cotangent could be rewritten as 1 over tangent using the reciprocal, or we could use the quotient and rewrite it as cosine of theta over sine of theta. Once we do that, what do we notice? Well, we notice that the cosines of thetas will cancel out, so that will leave us with 1 over sine of theta is equal to cosecant of theta. And then 1 over sine of theta is our reciprocal for cosecant, so we can rewrite that as cosecant of theta is equal to cosecant of theta. So that's what we're doing, is trying to kind of prove that those two things are equivalent. So on part B, we have secant theta plus tangent of theta times secant of theta minus tangent of theta. We could kind of start to mess with these, but let's go ahead and distribute here and kind of see what happens. We got secant squared of theta, and those are conjugates of each other, so their middle term is going to cancel out. So this right here would be secant of theta, tangent of theta, and then be the negative, and then tangent of theta, secant of theta would be the positive, so those will cancel. So all we're left with is minus tangent squared of theta is equal to 1. Well, secant squared minus tangent squared of theta. Let's actually go back to our Pythagorean identities, and you'll see right here secant and tangent squared are in there, but not written the way that we see. So I'm going to go back, and the identity is tangent squared of theta plus 1 is equal to secant squared of theta. Well, if we subtract tangent squared to the other side, that'll leave us with 1 equals secant squared of theta minus tangent squared of theta. So now you can see how these two are now equivalent, and so we know they equal 1. So we have secant squared theta minus tangent squared theta is equal to 1, so 1 is equivalent to 1, so that is a true statement. So now we're going to look at the complementary angle theorem. We know complementary means two angles that add up to 90 degrees, so our two acute angles A and B will add up to 90. These side lengths are opposite or adjacent depending on which angle you're actually looking at. So what I want you guys to think about is if I say sine of angle B, so that ratio of sine of B would be opposite, which would be B over hypotenuse C. What is another trig function that would give us that same ratio? Think about that. What's another trig function that would give us that same ratio? And so the one that would work would be cosine, but it'd be cosine of angle A. So cosine of angle A would be adjacent, which would be B over hypotenuse C. So they have the same ratio, but we're looking at different trig functions. Let's do another one. Let's do tangent of angle B. So tangent of angle B would be opposite over adjacent, which would be B over A. And so think about what other trig function would give you that same ratio. And it would be cotangent of angle A. So cotangent of A would be adjacent over opposite, which is still B over A. And then the last one I want you to think about is secant of B. Secant of B has the ratio of C over A. Remember, secant's the reciprocal of cosine. So cosine would be adjacent, which would be A over C, but we're doing secant, so it's the reciprocal, which would be C over A. And then the one other trig function that would match up with that ratio would be cosecant of A. So cosecant's reciprocal of sine, so it'd be opposite over hypotenuse, but it's a reciprocal, so hypotenuse over opposite, which would be C over A. These are called our cofunctions. So cofunctions of complementary angles are congruent. So that would look like this. If we have sine of theta, that would be equivalent to cosine of 90 degrees minus theta. Okay, remember A and B add up to 90. So if you take 90 minus A, you'll get B, or 90 minus B, you'll get A. Which is to say the same thing as cosine of theta would also be equal to sine of 90 degrees minus theta. And so this would work with all of your cofunctions: sine, cosine, tangent, cotangent, and secant and cosecant. Since those ratios are the same with different angles, we can rewrite these knowing now of the complementary angle theorem. So some examples you'll see: sine of 30 is equal to cosine of 60. So sine and cosine are your cofunctions. 30 and 60 are your complementary angles. Tangent of 40, cotangent of 50. 40 and 50 are your complementary angles, and tangent and cotangent are your cofunctions. And secant of 80 degrees is equal to cosecant of 10 degrees. Once again, complementary angles 80-10, cofunctions secant and cosecant. And so we know sine of 30 degrees is equal to cosine of 90 minus 30, which is cosine of 60. Same thing for the next one. Tangent of 40 is equal to cotangent of 90 minus 40. So those are your complementary angles, only with those cofunctions though. It only works with those specific cofunctions. You can't match sine up with anything else other than cosine. So example 3, use the complementary angle theorem to figure out what sine of 48 is. Now don't actually figure out what sine of 48 the value is, but a way to rewrite what sine of 48 represents. So sine of 48 is the same thing as its cofunction cosine of 90 minus 48. So sine of 48 would represent cosine of 42 degrees. Secant, its cofunction is cosecant, so cosecant of 90 minus 85 degrees, which would be cosecant of 5 degrees. And then cotangent of 3 pi over 8, that would be tangent of, and since we're in radians now, we'll use pi over 2 minus 3 pi over 8. So cotangent of 3 pi over 8 is equivalent to tangent. Find a common denominator, that would be 4 pi over 8 minus 3 pi over 8, which is going to be pi over 8. So tangent of pi over 8 is equivalent to cotangent of 3 pi over 8. So those are the complementary angle theorems using those cofunctions. So we'll now find some of the indicated trig functions based on the information given. You can use it by definition or identities. So for example, by using the identities, cosecant's the reciprocal of sine, so sine of theta is 1 over 7. Cosine of theta, you could either draw the triangle out, or you could say, I know that cosine squared of theta plus sine squared is equal to 1. So that's cosine squared of theta is 1/49th is equal to 1. And then if you subtract, that would give you 48 over 49. Take the square root of both sides, and the square root of 48 would be, let's see, square root of 16, so that's 4 square roots of 3 over the square root of 49, which is 7. So cosine of theta is equal to 4 square roots of 3 over 7. And we could also set up the triangle to figure out those values as well. Cotangent of 90 degrees minus theta. Well, remember, that's the same thing as tangent of theta. Well, what's tangent of theta? That was actually given to us. So that's the square root of 3 over 12. Secant is equivalent to cosecant of theta. And so cosecant of theta was also given in the problem, so that is an answer of 7. So that's using the definitions and the identities to work through some of these problems and figure out how to find each of their values.